Hi, this is Brother Tony, and now we're getting into Chapter 5, which talks about quadratic functions. So in this short lesson, we're going to take a look at defining the quadratic function, understand the properties of the quadratic function, understand how to complete the square, and then use that to understand how to get an equation into vertex form and identify the vertex. So let's get going. As always, please take good notes, stop the tape here, stop the video, go back if you need to learn something again. I'm talking quickly to try and keep your attention, but if I go too fast, you can always rewind. So first of all, right out of your book, quadratic function. Quadratic function, a function whose general equation is y equals ax squared plus bx plus c, where a, b, and c stand for constants. A cannot equal 0. If a equals 0, then you have y equals bx plus c, which looks exactly like a linear equation, except instead of b we have the slope, and c we have the y-intercept. Okay, so second thing we want to do is understand the properties of a quadratic function. So what I did, I went into GoodGrapher and graphed this, y equals x squared minus 6x plus 2. Now what you'll see right here, the lowest point in this case, or if the parabola, the quadratic equation, the curve, points downward, this would be the highest point. Either way, that point is called the vertex. And the vertex is an ordered pair. So what do we have? 1, 2, 3. So the x value is 3. The y value is -7. So that's where the vertex is. The second thing we want to do, you'll see a parabola, a quadratic equation, is symmetrical about the axis of symmetry. The axis of symmetry goes straight through the vertex. And while my dashed line is not absolutely correct, I hope you get the idea. We would call this the axis of symmetry. Make sure you're writing this stuff down, please. Now, what does the y-intercept equal? The y-intercept equals, so where does a parabola cross the y-axis? It crosses it at 2. Now, do you think it's just a coincidence that our original equation is y equals x squared minus 6x plus 2, and the y-intercept is plus 2? Probably not, because when x is 0, what are we left with? 2. Now there it's two x-intercepts. They are equidistant from the axis of symmetry. So the x-intercept equals roughly, we'll say about 0.5, and then also about 5.5, which if our vertex is on 3, both x-intercepts are 2.5 away from 3. So just as a review, for a parabola, for a quadratic function, you want to know where the vertex is. You want to know the axis of symmetry. You want to know the y-intercept and the x-intercepts. That'll be important, and we'll see a couple different ways to figure out how to do this. And most importantly, make sure you can graph these things. Point number 3 for this lesson, understand how to complete the square. Okay, why? Because we'll use completing the square to get this into vertex form. So a little review. We have this binomial, x minus 5 quantity squared. How do we do this? We write this as x minus 5 twice. And then we use the FOIL method. That gives us x squared minus 5x minus another 5x plus 25, which, all told, x squared minus 10x plus 25. Okay, now that we did it one way, let's do it in reverse. So let's say you have x squared plus 7x, And what you want to do, you want to get this into an expression that you can square the binomial. So what you'll see here, from what we did before, this -5 is half of the -10 right here. So -5 squared. So what are we looking at? We take half of 7. So half of 7 is 3.5 quantity squared. Now, as all of you know, 3.5 squared is 12.25. Okay. So x squared plus 7x plus 12.25 equals x plus 3.5 quantity squared. So the process of adding 12.25 to x squared plus 7x is called completing the square. That is important because when we get our equation into vertex form, sometimes we need to complete the square to do this. What is left out is you saw that I just seemed to add 12.25 to only one side. Okay? That's because I was simply doing an expression and not actually an equation. We'll see how this comes into play on the next slide. Okay, so I told you we'd be getting into vertex form on this slide. Well, you'll have to be a little more patient. I wanted to define completing the square. And look at it right down here. You can read the definition, but right here, half of the linear coefficient b. So b over 2 quantity squared. And that's exactly what we did in the previous slide. Okay. So let's see how this really works. So we have the equation y equals x squared minus 6x plus 2. Remember, that's the same equation that we graphed in Good Grapher. Let's complete the square. Now what do? We subtract 2 from both sides. That gives us y minus 2 equals x squared minus 6x. Now to complete the square on the right side, we take half of -6 and square it. So that's plus 9. So that is y minus 2 equals x squared minus 6x plus 9. But remember, we added 9 to this side. We now have to add 9 to this side to make the equation equal. So now y plus 7 equals the quantity x minus 3 squared. Okay, now look at this. What was the vertex? What was the vertex of the parabola? It was 3, -7. So we're very close to seeing this vertex form. And we'll get to that right now. Okay, here's what we've been waiting for, the vertex form. If the equation of a quadratic function is in the form y minus k equals a times the quantity x minus h squared, where a, and k are constants, then the vertex is at the point h, comma, k. Now, for those of you that are paying close attention, you will see the vertex form is y minus k. So pay close attention to the signs. Let's go through an example and you'll see. Y equals -3x squared minus 24x plus 11. Let's subtract 11 from both sides. Y minus 11 equals -3x squared minus 24x. Okay. Now what do? We have to factor the -3 out. That equals -3 times the quantity x squared plus 8. Let's go to this side. Now, we want to complete the square. So what does that mean? What is half of 8? Half of 8 is 4. 4 squared equals 16. Y minus 11 equals negative 3 times the quantity x squared plus 8 x. See how I made that mistake over there? Don't do that. Plus 16. Now, what do I put over here on the left side? I added 16 to the right, or did I? Not really. I added 16 times a negative 3. So what do I have to do? I have to add a negative 48 to this side. Y minus 59 equals negative 3 times the quantity x plus 4 quantity squared. Now where is my vertex? So where's my vertex? My vertex is located at negative h, negative k. So h is 4. So we want the negative of that. Negative 4. K is negative 59. We want the negative or opposite of that. So that is 59. So our vertex is negative 4, 59. When you graph this in Good Grapher, you're going to see the parabola opens downward. The reason that is, or the reason that you can tell that, is the coefficient of a, or a which being negative 3. So negative means that the parabola opens downward. What is the y-intercept? By now you should know that if x equals 0, that evaluates to 0, and so y equals 11. So those are the properties. If you understand that, you understand the properties of a parabola. That's all for this lesson. Hope you took good notes. Hope you reviewed that. Be ready to go in class.